All right, so here we go with 8.1. We'll go ahead and get started here. Okay, so it says write a similarity statement comparing the three triangles. That is one thing we should know, right? We have an altitude to the hypotenuse. We get three similar triangles. I'm just going to mark some angles. It'll make it much easier. So a Q and that angle will be congruent. That angle and that angle will be congruent. And of course, the right angles will be congruent as well. All right, so if I just start off, and let's just keep the pattern. Let's just do big, medium, small. So the big one, I'll go ahead and just do, let's just do Q, R, P. And again, yours might look different than this, but we're just matching them up. So Q is the single, R is the double, and then right angle. So single, double, right angle. So single, let's see, on the medium one is going to be Q. A double on the medium one is going to be P, the vertex is anyway, and then S is the right angle. And then you have triangle, and then we want to match up with the single of the small one, which is the vertex of that angle would be P, followed by the 2, which is R, followed by the right angle, which is S. Okay, then we'll do the same thing over here. I'm going to mark them. And okay, so we'll start with the big one. We'll just say B, E, D. And again, I did a little different. Not that, not that it matters, but B, E, D is 2, right angle 1. So 2, right angle 1. Of the medium one, 2 is going to be E, right angle is going to be C, single angle is going to be D. And then finally, of the small one, it was 2 is going to be B, then right angle is going to be C, and then E is going to be the single. All right. Let me just scroll with this. That'll work. All right, so we want to find the geometric mean of these values here. I'm going to see if I can change the thickness. It's a little... Okay. So the geometric mean is basically the geometric mean of two numbers A and B would be this, and that's sort of derived from the fact that we could say A over X equals X over B, right? The geometric mean. So in this case, the geometric mean of these numbers is just going to be radical 2 times 50, right? Which is just going to be X equals radical 100, which is just going to be 10, all right? And then this one, radical 9 and 12. So X equals, right, the geometric mean. And then 3 I can pull out is basically already a perfect square. And then 12 is 3 times 4, so I can pull out the 4, it would be 2. And then what's left is a 3. So we get 6 radical 3. All right. And then we get 4 and 16. Okay, so this is actually going to be nice because if we look, we get 4 times 16. Well, 4 and 16 are both already perfect squares. So pull out a 4, that's 2. Pull out a 16, that's 4. So this is just going to be 8. And actually that makes sense because 4 times 16 is 64. But either way, we get 8. All right, 16 and 25. This is going to be another nice one. Again, makes sense to think of it like 16 and 25. And yeah, you could multiply that and then take the square root and then break that down. But it's much easier to not do that. So we'll do 16 is 4. That's going to be 5. So 4 times 5 is just going to be 20. So that must have been 400 when they added up. Okay, not so bad. All right, so here we get to maybe some more challenging ones. We'll see. But basically, if you remember the rules that the altitude is the geometric mean between the two pieces, remember we can always do Pythagorean theorem. We're sort of good. So in this case, I'm going to find y, and so I can think, well, y is the geometric mean, right? So this altitude is the geometric mean between 6 and 4. All right, well, it looks like we can pull out 2, so 2 radical 6 is what y is going to be. I'm going to write it in there. Okay, and then I can use, I could find z actually by doing the geometric mean as well. So z is a leg, and it's going to be the geometric mean of the piece closest to it, 4, and the whole hypotenuse, which is going to be 10. All right, so that's going to be 2 radical 10 once we simplify that. And then finally, we could do x, which is going to be the same thing really as the leg here, so because it's the other leg. So we're going to have x equals, so the G